This video will talk about question 3, deals with the thin wall concept. Alright, so consider a cylinder with a dimensions diameter this and thickness this. Alright, determine the allowable working pressure if ultimate tensile is this and safety factor this. Alright, so how do we do it? When the first thing you see this type of question, you need to know which is the diameter and which is the thickness, right? And in this case, our diameter, I would assume, is a outer diameter, alright, meaning a cylinder over here. They're talking about the outer diameter, alright, or this particular silhouette, alright, with a certain thickness 11 mm. Alright, so I'm going to determine whether is it thin or thick, but by the values you most likely think that is thick. I mean thin, sorry. So DO over T, and please take note that this ratio, please use the outer diameter, or don't use the inner diameter. Okay, so what I have is 1150 over 11. What I have is 104.5. Alright, and if you want to just take note of the units, is mm cancel, is just some ratio between the units. Alright, for this is actually greater than your tenth. Alright, they actually state that before, right? So if it's greater, this means that you are thinned. And thin, then we're going to use the thin formula. Alright, we know that sigma r for the thin is actually equals to 0. Alright, the radial stress, if you still remember. So these are the hoop stress, right? It all goes in this circular stuff. We call sigma theta theta. Or if you take a cube of this, alright, something like this. Alright, so this is your longitudinal stress, your sigma zz, because you're talking about the axis. Alright, this is x, this is y, this is z. So you're talking about this axis, so the stress that is over here is sigma zz acting across this. Alright, while the this movement is sigma tt going around this loop. So the loop rhymes with the hoops. So the hoop is the hoop stress. Alright, and then there will be a certain if you look into the picture, there will be a certain sigma rr. This is your radial stress, alright, going into this. And because we can assume, because it's so thin, that we can assume that this is somewhat neglected, because the outside pressure is so huge that we can actually assume comparatively this sigma r can be neglected comparatively to the pressure outside. But in this case, our pressure is also nothing outside, so we don't care about anything. Alright, so sigma r is simply equals to 0, and that's it. Happy. Okay, now sigma theta theta, what the hell is that? Sigma theta theta, the equation is equals to PR over T. Alright, and sigma zz, the equation is equals to PR over 2T. Just remember that sigma theta theta is always larger than sigma zz. So therefore, you have no divided by 2. Alright, sigma zz has divided by 2. So therefore, this is it that we can calculate and know that sigma theta theta is always larger than sigma zz because of this factor of 2 divide, or if you want to remember. Alright, so we actually know that the working pressure, what is it? In fact, we are actually given the ultimate tensile as 460. Alright, this is our so-called the U maximum stress you can take, alright, from the material itself. Alright, so you must be lesser than this value. Alright, or just take it as equals first. Alright, and then N times your sigma hoop stress. Alright, if you still remember, this is the safety factor, alright, multiplied with your stress. So therefore I can just bring it down over here as divided by N. Alright, maybe I should bring it down here now. Anyway, hold on. Okay, and just please take note that we are only taking about this pressure. We want to know this value, and that's it. Alright, and in fact, the purpose of us finding the hoop stress is because, as we say, PR over T, alright, is always larger than PR over 2T. For example, if PR is 100, T is 2, then you have 50. If PR is 100, then 2 times 2, because T is 2, you have 4, which is 25. As you can see, there is a factor of 2 difference. So therefore, sigma theta theta is always the big one. Alright, it's always the big one. So you're going to compare the big one. And therefore, we know that sigma theta theta is actually PR over T. Alright, where this R over T, okay, is 104.5 divided by 2. This is your ratio. Alright, because DO alright, is over 2RO. Alright, so the diameter is 2 times the radius, right? So this 2 will bring down over here, divided by 2. So 1150 divided by 11 divided by 2, you have 104.5 divided by 2. So this one is this value. So I'm just simply divided by 2 lah, okay? But please be very careful that this is R over T. Alright, what we calculate just now is D over T. So therefore, be very careful when you sub in the values, because you may actually accidentally sub in as diameter. Alright, let's take note that this is the radius. Alright, the radius outside. Alright, because you can find inside, but why not? Because we already given some radius already, then you just find outside lah. Alright, just what we have is that 460 divided by 4, then further divided by this whole R divided by T. Alright, R divided by T is actually 104.5, which is approximately 52.25. Just sub it over here. So I have my pressure, working pressure over here, including the safety factor over here. So let's calculate. So this is MPa. There is no unit for safety factor because it's just some ratio. There is also no unit for this. It's because this is also some ratio between the radius and the thickness. Mm and mm cancel out it. So therefore, what I left is only 2.2 MPa, right, with the particular unit over here. So this is it. This is your answer for question 3. Your working pressure included with your safety factor of 4. So the takeaway is that, remember, this is your N, your safety factor times your stress, compare to your stress maximum, alright, the maximum that you can take, right, or the ultimate stress, alright, the ultimate tensile stress. Okay, so I'll see you in the next video for question 4.